Hello, Grade 9 learners. Welcome to today's mathematics lesson. My name is Rosem Timunye, and this lesson is proudly brought to you by the Gauteng Department of Education. I hope you are ready for today's lesson. Don't forget to save our WhatsApp line 079 35. You can save it as your favorite lesson. All right. So you are going to use that number to send us pictures of your work and also to ask any questions if you need clarification on anything that we are discussing today. Also, if you would just like to give us some comments regarding today's lesson, please do use 079 454 9535. All right. So you remember last week we covered perimeter and we were looking at the perimeter of polygons, right? So today we are doing the area of 2D shapes. So we are going to look at both polygons and circles as well when we do this lesson. Now, today's lesson, you definitely need a calculator. Make sure you've got one in front of you, okay? And the pencil and the ruler also are going to be useful when you do this lesson. If you've got colors, please do grab them. You know we love color and it helps us to strategize our working out, okay? So let's look at the lesson objectives for today. By the end of this lesson, you should be able to use appropriate formulae and also conversions between units to solve problems and also calculate the area of polygons and circles. So today's questions are mostly the types of questions you will find in an exam. So you definitely need your thinking caps on, okay? And your pre-knowledge will include substitutions, equations. You need to remember your classifications of triangles as well, the theorem of Pythagoras, also your properties of quadrilaterals, and obviously perimeter and area of 2D shapes as well. This is your baseline assessment. The first question, you have to find the length of DC. And then the second question, we have to calculate the perimeter of the store. Very important that you actually start off by reading the whole incept, okay? And then making sure you read it again and then trying to answer the question. Remember, we use the 3 R's: read, and read one more time. Okay, so I'm going to give you time to do the first question. And after that, I'll give you time to do the second one. So you have 3 minutes to answer number 1. And then I'll give you 2 minutes after that to answer number 2. Okay, so you have 3 minutes. Welcome back, class. So now let's see how you did with the first question. Okay. ABCD is a right angled triangle. Did you notice that? Because we are working with a rectangular shape, right? This is where reading the question helps, right? It says Sam is building a store for his horse and needs to know how much paneling he will use. He draws this plan where ABCD is a rectangular store with BD is equal to 10 meters and BC is equal to 6 meters. Now, when you read the part about it being a rectangular store, you would obviously remember that the angles, the corners of each of these are 90 degrees, right? So that means the side you are looking for, DC, all right, can be found using the theorem of Pythagoras, all right? Now, you know the standard theorem of Pythagoras would have been the hypotenuse squared is equal to BC squared plus a DC squared, right? And your hypotenuse here is DB, okay? But now we are looking for DC, therefore we have to use the hypotenuse and subtract the other side. So we'll say DB squared minus a BC squared. Okay, right. Then now from this part, you now need to substitute the values. You've got 10 squared and 6 squared. Now you've got 10 squared minus 6 squared. That's 100 minus 36. And then DC squared will then be equal to 64. Right, we square root both sides and we get DC to be equal to 8 meters. Okay. For this question, you are going to get a mark for having the correct statement and reason. Your correct substitution also gets you a mark, and also getting the value of DC. Right. Okay. I'll just give you 1 minute to quickly do this and then we'll move on to the next question. Okay, class, let's look at the next question. The next question says that you must calculate the perimeter of the stall. Okay, so for this question, I'm just going to give you a quick 2 minutes. The trick is that you must actually put all the measurements of the shape before you do the calculation. It will make much more sense. Remember, you've calculated aside, write that information on your diagram as well. Okay, you have 2 minutes. All right, welcome back, class. So let's just do this one. The perimeter of a rectangle is given by twice the length plus twice the breadth, right? 2 times L plus 2B. So here we are using AB and BC as our length and breadth. So it'll be 2 times AB plus 2 times BC, okay? And then from there, we substitute the necessary lengths. Where did we get this 8? It's the one we calculated earlier when we needed to use Pythagoras for DC, okay? Don't forget that you could have chosen any of the sides, right? Because these two are equal and AB is equal to DC there. 2 times 8 is 16 plus 2 times 6 is 12. We add those two, we get 28. All right, for this question, you would get a mark for correctly substituting and your final answer. I'm just going to ask you to please quickly do your corrections while I am on screen if you need to. Well done if you got a full mark. So if you even got 1 or 2 of the steps correct, good job for attempting this work. Do send me a picture. Let's see how we can assist you or even just congratulate you if you did extra well. Okay, on 079-454-9535. All right. Okay, let's get into some of the concepts associated with today's lesson. Starting off with a 2D shape, we are doing the area of 2D shapes. So that would be a geometrical shape that has 2 dimensions, okay? We can call them length and width, all right? Remember, these are mostly because your shape will usually have a distance around it and also a width to it. That's basically it. Don't think about it in terms of length and breadth of just a rectangle. Okay. And then you have area. Now, area, we're measuring the amount of surface on a shape, right? So hence we are looking at these 2D shapes. Some things you need to remember with your conversions, right? I think you still remember this mnemonic. King Henry died a miserable death called measles. We really use some of them, such as the hectometer and the decameter in our current grade, but it's good to know them because with the continuation of your grades and even in university, you end up needing to use the conversions, right? So with area, we use square units, hence I've squared all of these as well, right? When we go from a larger unit to a smaller unit, we multiply by 100 or 10 squared to get to the next unit, okay? So for example, from kilometers to hectometers, it would be times 10 squared. But from kilometers to decameters, what would we do? We would use times 10 squared times 10 squared to get to decameters. Make sense? So don't skip one of them. Just remember that you must use all of them. Okay. So it's either you use 10 squared or 100. I wrote it as 10 squared so that you remember that the area is measured in square units. Then we also can go back, all right? So we use division when we're going from smaller unit to a larger unit. So we divide that smaller unit by 10 squared or 100. Okay, then there's specific measurements that you definitely must make sure you still remember how to do. Being able to convert between kilometers, meters, kilometers squared, centimeters squared, and millimeters squared is very, very important. Those units are important even in their linear form. It's just kilometers, meters, centimeters, and millimeters because those are the ones we use quite a lot in our questions. Okay, so do practice converting between them. All right, now we get to the formulas that we use to calculate the area of some of our shapes. Starting off with a square. You know, a square is a regular polygon. All the sides are equal. So you can have side and side, side here, side there. They are all just equal, right? So your area will be equal to side squared. And then a rectangle has a longer side and a shorter side, right? So the area of a rectangle is given by the length times the breadth. Right? You know these two formulas. I'm just reminding you of them. Okay? Don't worry, you don't need to draw the shapes as such. Just write the name of the shape and the formula. The name of the shape and the formula. I'm just reminding you of some of the properties you need to remember to recognize that it's a rectangle or if it's a square. Okay? And then there's a triangle. Now, a triangle is a standard. We have a right angle triangle like this one where we have a base and a height. That's easy to recognize, right? But sometimes you find that it's not easy for you to recognize which part is your base and which part is your height. Why do you need to recognize those? Because the formula is half times base times height, right? So it's important for you to remember that your height of a triangle will always be perpendicular to the base, right? Now, sometimes the height might not necessarily be inside the triangle, right? So you would be able to draw it outside, still perpendicular to your base, right? And sometimes the height will actually be the height of the triangle inside, so you can also do that. All right, so do practice these all these versions and understand how to recognize which part is your height in a triangle. Okay, we also are going to do area of circles, so we need to remember some of the formulas used with area of circles. Starting off with a full circle will have a diameter and the radius, right? So a diameter would be the distance that goes from the circumference through the center to the circumference, and then your radius is from the center to the circumference. Okay, now here the formula is pi r squared when it's a full circle, and then if it's a semicircle, half a circle, we just half the formula for the full circle. So it's half times pi r squared. So it's half of a full circle. And then if it's a quarter circle, we use half of a full circle. We use quarter of a full circle. So it's 1/4 times pi r squared, right? Now, the only thing that I think you would note as a difference between the formulas we are using is that here it doesn't matter whether the circle is the semicircle is open or closed. Like we had to pay attention to that when we were doing perimeter, but with a circle we're just looking at the surface, so it doesn't matter whether it's an open semicircle or a closed semicircle. Make sense? Okay, all right, we get into some work. Right, so these questions are actually from some past papers that we've seen before. These are questions that you could end up meeting in some of your exams, so do practice them. If you feel confident answering these types of questions and you've created a strategy that helps you to answer them, you find that when you see them immediately you want to do them first in your paper as well. So it says the area that has been shaded in that diagram has an area of 21.8 centimeters squared, and you're asked to calculate the diameter of the semicircular hole, giving your answer to the nearest millimeter. All right, now we've read it once, right? The next part is for us to actually read it and understand it. So we are told that the area that is given here, this 21.8, is just the gray part of the shape. Okay, but we are asked to find the diameter of this semicircular hole. Make sense? Okay, so first, for us to be able to find the area of the semicircle and then get the diameter, the first thing we'd have to do is to actually get the area of the full shape. So the full shape is a rectangle, therefore we are going to use length times breadth, and then that's 9 centimeters there times 6 centimeters, and then we get 54 centimeters squared, right? So we've calculated the area of the full shape. Why do we need this? For us to get the area of the hole, we would need to use the area of the full shape and subtract the area of the shaded shape. So it will be the difference between the two. So the area of the semicircle would be equal to the area of the rectangle minus the shaded area. Now the area of the rectangle, we've just calculated it. It's 54 centimeters squared. And then the area of the shaded part is 21.8 centimeters squared. All right. If you've noticed, we've had to go back to our question how many times? 3 times. Hence, I said you read, read, and read. Now, we've got our information. So we substitute those values, 54 centimeters squared minus 21.8 centimeters squared. And then you get your answer to be 32.2 centimeters squared. Okay. Have you actually answered the question yet? No. All you've done was calculate areas of different shapes, but you still haven't found the diameter of the semicircular hole. So the diameter would be from one end of the circumference through the center to the circumference again. Now, what we do there is to use the area we've just calculated for the hole, okay, and substitute it into the formula for half a circle. That would be half of pi r squared, right? So we substitute 32.2 is equal to a half pi r squared. And then how do we remove the half now? We multiply both sides by 2, okay? Then you're left with pi r squared on your right. Note they told us that pi is equal to 3.14, so we are going to substitute the value for pi. All right, so first we divide both sides by pi, and then we substitute 3.14 for pi, right? All right, remember I've suggested before that before you do your final answers or substitutions, do your best to simplify the expression as much as possible. Hence, we are only substituting pi at this stage, because then it would have meant moving decimals around, okay? All right. Have we answered the question? Are we even done yet? Not yet. We are going there, right? Now we still have r squared. What is the diameter actually equal to? The diameter is equal to twice the radius, right? It's 2 radii, because if you go from the center here to this side, that's 1 radius, and from the center here to the other side is the second radius, right? And so we need to first get what 1 radius is and then multiply that by 2. Okay, to remove the square, we square root both sides. Note, I haven't simplified the fraction because I'm not yet at my final answer. Then I get r to be equal to 4.5 centimeters. Okay, once we've done this, the next part we multiply r by 2, because now remember we've just discussed that a diameter is 2 radii. So it will be 4.5 times 2, which gives you 9 centimeters. We go back, we read our question one more time. It tells us that we must give our answer to the nearest millimeter, right? So that means the 9 centimeters we calculated must be converted to millimeters, and that means the diameter is equal to 90 millimeters, okay? All right, so just to recap quickly, what we had to do here for us to be able to find the diameter was to first find the area of the full rectangle, and then subtract the area of the shaded part from the area of the rectangle to get the area of the hole. Then once we had the area of the hole, we substituted the area of the hole into the formula of half pi r squared, right? We used our semicircle. And then we solved for the radius. And remember, the radius times 2 is equal to the diameter. Hence, we got our 90 millimeters. Okay? Right. This was A. Now, let's see what B requires of us. All right. Okay. So, the second question is actually based on triangles, and this you are going to have to practice, right? It says in the given diagram, the area of triangle STU is 150 centimeters. Okay, you have to calculate the length of TU, right? I am tempted to give you a hint, but I really would like to see you try and also give you the opportunity to test yourself, right? So if you are struggling, do send me a WhatsApp on 079 Show me what you've done, and let's see how we can help you moving forward, right? But do try these questions. I'm going to give you 5 minutes to answer these questions, and when you are done, we are going to do the solutions. All right. How was this activity for you, class? I hope you had a bit of fun trying to figure this one out, right? Okay, so when we look at the first question, it says calculate the length of TU, and you've actually been given the area of triangle STU, right? So let's start there. It says in the given diagram, the area of triangle STU is 150 centimeters squared. Now, the marks should already give you an idea that you are going to need to do a bit of work in order for you to solve this, because it's out of 4 marks, right? Now, to calculate the length of TU, the first thing you actually need to do is to find the side SU. Okay, that would be the first thing you would want to do. So to find the side SU, we are going to use the given area and substitute it into the formula of half base times height, and our base is going to be 20 centimeters. Remember, the base and the height are perpendicular to each other, so we are using the two sides ST and SU because there's a right angle right there by S, so we are using the two sides that are perpendicular to each other. So we'll substitute 20 for ST, and we'll substitute 150 centimeters squared for the area, and then we are looking for SU. We get the side SU times 20 to be equal to 150 times 2. This is us removing the half, right? We are multiplying by 2. Then you divide both sides by 20, okay? So remember, you're still isolating SU. Then SU becomes 15 centimeters, all right? This is the first part. So if you have 15 centimeters here, you get a mark, right? You could have used a different method, but as long as you got 15 centimeters there. All right, now the next part is for us to now say, okay, we know now this is 15 centimeters there, right? So we have two lengths. Should be easy. Don't forget, STU is actually a right angle triangle, right? Because at angle S, we have a right angle. So that means that we actually can find TU using the theorem of Pythagoras. Yes, because TU is now the hypotenuse of this triangle, right? So we write down our theorem of Pythagoras. TU squared is equal to TS squared plus SU squared. We substitute the value of TS and also the value of SU, then you square them, right? You get 400 plus 225, that gives you 625. Then TU will be equal to 25 centimeters, okay? So for correctly substituting into your theorem of Pythagoras, you get a mark, and then simplifying TU will also get your mark and also your final answer there. All right, so these are the steps you should have followed with this activity. So I'm going to just give you a quick 30 seconds while I'm on screen just to quickly copy this part, because now you recognize that what you had to do was to find the missing side and then use your theorem of Pythagoras, right? So I hope you are almost there with the corrections, right? I just need you to understand what you should have done. You can still practice this question again a bit later on. All right. Have you saved our WhatsApp line? 079-454-9535. Also send us your questions. Send us the pictures. Let's see how you are solving this work. Let's see the methods you've chosen to use. Remember, there's quite a few methods you can choose to use when you are working with these types of questions. Okay? I hope everybody has this part down. Now let's look at the next question. It says determine the value of x, and this question is out of 3 marks, right? Now x is actually the length SV, and that is the height of the triangle STU. Do you see that? Okay, it's usually what you would see as a dotted line in a triangle going up to the apex of your triangle. So triangle STU has an area of 150 centimeters squared, right? So the area of STU is going to be equal to half base times height. Now we are going to use which one is our height? SV, which is the length X. Okay, that's the height we are using this time. All right, so we substitute 150 into 1 over 2x times 25 on the right hand side. Okay, and then we multiply both sides by, we divide both sides by 25. Let me just show you the steps we are missing. We have 150 is equal to 1 over 2 times x times 25. So we divide by 25 here, divide by 25 there. Okay, then once you've done that, the next thing will be now for you to multiply both sides, because you now have 6 is equal to a half x. So you multiply this side by 2 and also multiply that side by 2. Okay, and what do you get? You now get x to be equal to 12 centimeters. All right, so far we have 15 there, we have 25, and we have 12. So we have actually found all the dimensions of this triangle. All right, okay, so I'll just give you 1 minute to quickly do these corrections, and then we are going to move on to the next question. Okay, class, so let's look at the area of a parallelogram, right? This is a short investigation that you can also do when you get home, just to practice and have a little bit of fun, okay, while you learn something new. So what you're going to do is to cut out a parallelogram shape out of a piece of paper, right? And then you cut off the parallelogram, like you draw this line here, all right, and then you cut off a piece of the triangle. Okay, and then once you've cut this piece off, what do you do with it? You now slide the piece towards the right. Okay, that's translation. You slide it onto the other side where you didn't cut, then join it onto that side. All right, and then this is the shape you should have. What shape is this? This is a rectangle, right? Okay, now let's quickly just remind ourselves, what is the area? How do we calculate the area of a triangle? It's base times height, right? Okay, so that means this side of our rectangle would be the height. This side, this is our heights in this case, because it's now the height of the triangle. So we are going to write down the area of a rectangle standard first, right? Length times breadth. Then we are going to use now, let's call our base, the whole shape, the bottom part and the top as bases. Okay, then we are going to use the length as the base, and then multiply it by the perpendicular height of the triangle, that's the h. Okay, so now your general formula for the area of a parallelogram will then be given as the product of the base times the perpendicular height, right? And the perpendicular height is the height you would have drawn when you cut your triangle. Okay, and we write this as A is equal to B times H. Right. What I need you to do here is simply write area of parallelogram, and then write A is equal to B times H. I do have a table though, so you can wait until we look at the table and then you can just quickly copy the formulas from the table. All right, we're just going to look at two more quadrilaterals quickly. All right, so we have this activity to test us in understanding how we came about the formula of the area of a parallelogram. It says the diagram below shows a parallelogram with sides 7,3 centimeters, 5,5 centimeters, and a height of 3,8 centimeters. All right, you have to calculate the perimeter and the area of the parallelogram and then convert the area to meters squared. So here I'm going to give you 4 minutes to start this activity. Once you are done, we are going to discuss them, and whichever question you are not done with, it's okay. We'll do work on it together. So you have 4 minutes. All right, class, how are you doing so far? I hope you are still having a bit of fun and are enjoying some of the challenges that we are coming across with these activities, right? So don't forget, I'd like to see how you are doing. So send me that WhatsApp on 079 454 9535. Okay? All right. So the first thing we had to do here was to calculate the perimeter and the area of this parallelogram. Now you remember your rules with a parallelogram, right? Or the properties of a parallelogram. The opposite sides are equal. So if this is 5.5 centimeters, this side is also 5.5 centimeters. The side will be 7.3 centimeters as well, because that one is 7.3 centimeters. So now, when you think about that already, you know that you're going to have 2 times 7.3 centimeters plus 2 times 5.5 centimeters when you do your perimeter. Doesn't that sound almost like that formula we use for the perimeter of a rectangle? Twice the length plus twice the breadth. Right? You see how these two shapes are related, right? Okay, so the perimeter will be equal to twice 2 times the first side plus the second side. So 7.3 plus 5.5 times 2. And that gives you 25.6 centimeters, right? You could have just easily added 7.3 plus 5.5 centimeters plus 7.3 plus 5.5 centimeters. That is still very much acceptable. Okay, so if you have done 7.3 plus 5.5 plus 7.3 plus 5.5, like this, that's acceptable as well. Okay, to get your perimeter. Okay, that's fine. All right, and then the next part, we had to calculate the area. So your area is given by the base times the perpendicular height. So you have 7.3 times, this is your height, it's perpendicular, there's your right angle, 3.8 centimeters. So you get the area to be 27.74 centimeters squared. Okay. Right, so I'm just going to give you a quick minute to do your corrections for this question, and then we are going to move on to the next question. 1 minute. Okay, let's look at the next question. You had to convert the area to meters squared. So the area was in centimeters squared. Now remember, when we convert from a smaller unit to a larger unit, we divide, right? And I said we divide by 10 squared or divide by 100, right? So here the centimeters are already squared and we are converting to meters squared. So we are squaring the 100 as well. Okay, so we are going to divide 27.74 by 100. Remember, when you divide, you move the comma back. So you just need to move the comma back by 4 zeros, right? Hence, we are at 0, by 4 places. We are at 0,002774. Right. If you written it as times 10, as a base of 10 as well, it's also okay. All right. But what you should have recognized here is simply I wanted you to be able to just use this part, being able to divide by 100 squared, understanding that that's what you need to do. Okay. All right. So for this question, I think you already have your corrections. It's simply typing it into your calculator. Let's look at the rest of the areas of the quadrilaterals. Remember, I did promise that we have a table with all the areas of a quadrilateral. So the area of a trapezium is equal to half the sum of the parallel sides multiplied by the perpendicular height. All right. So if we have a rectangle, a trapezium like this one, pardon, and we've named our sides, then it would be half times b plus d times a height, right? So be very, very mindful here. This is going to be dependent on the length of your sides, all right? So, or what the sides have been called, okay? And then the area of a height is equal to the product of the diagonals divided by 2. So your diagonals would be DB and AC in this triangle. Be mindful of that when you are working with a different triangle. Use the correct names. Alright. So it'll be AC times BD divided by 2. Okay. These are the formulas. I'll just give you 1 minute to quickly copy these formulas because they will come in handy as you continue with your area lessons. Okay. I hope you have these formulas because you are going to need them to answer this question. Right, activity 3 is going to be your homework. Please, please, please practice it. You've got marks on these questions. So I'm going to give you 2 minutes because I really would like you to practice this. I'm going to give you 2 minutes to copy it as part of your homework, and then we are going to move on from there, right? So we won't be able to do it today. So just copy it for your homework. 2 minutes.
Believe in yourself. Believe a little more in yourself. Because to those that believe, nothing is impossible. You have done this before. You have passed your tests before. You have went into a higher grade before. It is possible because you have done it before. Do not doubt yourself. Keep believing in yourself. Keep pushing because this can be done and you can be great.
Okay, so you do actually have more homework, right? So I'm going to ask you also to do this one because it's calculating area. So I'd like for you to just quickly take a picture of this one as well. All right, a picture or a screenshot very quickly while I am on screen, please. We are going to also do this as our homework, all right? So you just have a kite, A, B, C, D, and then you are given the length there. All right, I'm mentioning this for the person who's writing. So BO is equal to OG, it's equal to 6 centimeters. OC is equal to 15 centimeters, and AD is equal to 10 centimeters. Okay, all right. Okay, now I don't have any WhatsApp questions from you at the moment, but thank you so much to those who have interacted with us, asking with any comments that you may have sent to us. So we are now going to look at our summary quickly. All right, the theorem of Pythagoras can be used to find the lengths that are missing in a right angle triangle, right? So here you just add right angle triangle. We use c squared is equal to a squared plus b squared. The formula for area of parallelogram comes from that of a rectangle, right? So we use area is equal to the base times the perpendicular height. Then the area of a trapezium is equal to half the sum of the parallel sides multiplied by the perpendicular height. Then the area of a kite is equal to the product of the diagonals divided by 2. So these are all formulas, just we've used their definitions because sometimes we don't need specific letters. We depend on how the shape has been named. Okay. So I'd like to say thank you so much for joining us today. This lesson is proudly brought to you by the Gauteng Department of Education. My name is Rose Mtimunye. Do join us next time.